In this video, I'd like to talk about the math question of the day for Friday, April 14th, 2023. And with this problem, we need to use the properties of logarithms to expand this logarithmic expression where we have the natural log of this input here. And to answer a question like this, you will need the tools of Algebra 2 and most likely PreCalculus. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through it. And if you do have suggestions for future questions of the day, feel free to leave those as comments. Now, with logarithms, there are several different properties we could use. One property that we can use is that if we have a logarithm, and I'll just use the natural log for these. Let's say we have the natural log of a raised to the b power. We can rewrite this as b multiplied by the natural log of a. So if your input is raised to some exponent, you can just bring that exponent down in front and you will have multiplication. And ultimately, all of these logarithmic properties come from basic exponent properties because logarithms are just exponents. So in some sense, this is related to the property that an exponent to an exponent you multiply. If you have 2 cubed and you square that, you will end up with 2 to the 6th power. So these are related properties. And we do have an exponent here. We can rewrite this as the natural log of x squared multiplied by x plus 2, and all of this is raised to the 1/2 power since we're dealing with a square root, and since we're taking a second root, the exponent will have a 2 in the denominator. The denominator of our exponent, remember, deals with what root we're taking. So to start, we can just bring this 1/2 out in front. We have 1/2 the natural log of x squared multiplied by x plus 2. And the next step is to recognize that we have a product inside of our logarithm. And the exponent property that we'll need to use here, let's say we have the natural log of c multiplied by d. If we have a product on the inside, we can separate this into the natural log of c plus the natural log of d. So a product on the inside allows us to split it into a sum of 2 logarithms. Likewise, if we have a quotient, if we had c divided by d, we would just have subtraction. And again, this is related to exponent properties, particularly the fact that if we have, let's say, 2 cubed multiplied by 2 to the 4th, as long as they have the same base, like they do here, we have base e since we have a natural log, we will add the 2 exponents together. So if we're multiplying, it's addition of the exponents. So these are related properties. And we do have a product here, so we can separate this, and we can rewrite this down here. Let me just make a little bit more room for that. And we have the expression 1/2 multiplied by the natural log of the first factor in our product, which is x squared, plus the natural log of the second factor in this product, which is x plus 2. And of course, this 1/2 will distribute to both, so let me just quickly rewrite that so that we have 2 separate terms here. And lastly, we can again use this exponent property. We have our input raised to the 2nd power, so we can bring that 2 out in front and use multiplication there. I'll make just a bit more room. We would bring the 2 in front. We have 2 over 2, which is 1. So this is just the natural log of x plus 1/2 the natural log of x plus 2. And this right here will be our fully simplified and expanded logarithm. Now, one way to test this is to pick some value for x and plug it into the simplified expression and the original expression and show that we would get the exact same output. So for these, it can be a little bit messy since natural logarithms in particular we'll often deal with irrational numbers, but we can get a rough idea. Let's just set x equal to 1, since that is in the domain here. We can actually evaluate that. We would have the natural log of 1, so e raised to what power gives us 1, and that would just be 0, plus 1/2 the natural log of 1 plus 2, or 3 in this case. And again, this would be 0, so we just get 1/2 the natural log of 3. And let's see if our expression up here will simplify to the same value. We're just setting x is equal to 1. So let me just make a little bit of space here. And when x is 1, we have the natural log of the square root of 1 multiplied by 1 plus 2. So 1 times by 3, which is the natural log of the square root of 3. And at this point, you could use the exponent property to show that this is really just 3 to the 1/2, and then you can bring the 1/2 out in front. But if we want to avoid using exponent properties to check this, since we use that to actually simplify everything, we can just plug both of our expressions into the calculator and show that this is approximately equal to 0.5493 and so on, since it's irrational. And we can apply the calculator to this expression as well and show that it also is approximately 0.5493. So that's just one way to check it, to actually plug in some value and show that when you plug it into the original expression and the simplified expression, you do actually end up with the same decimal answer.